All right, there are a couple different ways to sketch a graph of a linear equation. We could find a few solutions, plot those solutions, and draw the line connecting them. Or we can use slope-intercept form, which is what I'm going to do with this example right here. The first step when we're going to use slope-intercept form is to solve this equation for y. So first thing I'm going to do is I'm going to add 3x to both sides of the equation, giving me 2y equals 3x plus 2. And then I'm going to divide everything by 2 to get this y isolated. And that would give me this equation of y equals 3/2 x plus 1. So when our equation is solved for y, or it's in slope-intercept form, these coefficients, or the numbers on the right-hand side of this equation, give us really important information. This 1 right here, what we call the constant coefficient, this tells us our y-intercept, and in this case that would be 0, 1. Y-intercept, by the way, always has a 0 for an x value, and then the y value for that y-intercept comes from that constant coefficient. Meaning here on the graph, if I want to graph a point, I already could. I know that is a starting point for the graph. Then this 3/2, what this is the slope. The slope equals 3/2. Slope is the steepness of our line, or of our graph, and simply we call this the rise over the run, is the way that we describe this steepness. So what we do with the slope is we're going to use this rise of 3. This is up 3 units, and this is to the right 2 units. That information will give us our next point. So we go 1, 2, 3 up, and then 1, 2 units to the right, and that gives us our second point right here. Again, it's up 3 units and to the right 2 units. Once we have those 2 points, then what we need to do is just connect them with a line. And just to recap, this is the line that has a y-intercept of 1 and has a slope of over 2 units and up 3 units.